Hello girls, let's discuss about the differentiation today. Okay, so let's take a straight line equation. Okay, so how can we draw a straight line? So this is a coordinated plane, x-axis and a y-axis. Okay, assuming we have a straight line which is passing through origin and having a slope of 2. Okay, so what is the equation? Passing through origin and having a slope of 2 plus 2. So what is the equation for that line?
Y equals 2.
Huh?
Yes,
Y equals
2x minus 2.
Y
2x, that's it. Because it is passing through origin. Why we need to keep minus 2?
No, like
So y is equal to 2 is going to be straight line like this. Okay,
Y equals
if I say
2x.
a straight line passing through origin and having a slope 2, the equation of that line is going to be y is equal to 2x. Okay, so this is y is equal to 2x.
No. Is the slope is
1, eh?
Yeah.
No, it's not 1. The slope, see,
How can
if
we
it is
do?
exactly at the middle, if it is cutting x and y exactly at the middle, then y is equal to x. But this is tilted towards the y axis. So the equation for this straight line is going to be y is equal.
It's very.
It's a steep.
very
It's a
equal.
steep, right?
It's so
It's
equal.
inclined towards the y axis. That is why the slope is more than 1.
Okay.
So I've picked up a 2. The slope as 2. Alright, so y is equal to 2x. Okay, so let's take some points. 1 here, 2 here, 3 here, 4 here. So what will be the corresponding y if it is 1?
2.
2.
1.
Okay,
2.
isn't it?
2.
Darshini, yeah, 2. So for example, if it is 3, what will be the y, corresponding y? 6. Okay, 6. If it is 2, what will be the corresponding y?
4.
4. Because it is obeying this equation. So if you want to know the y coordinate, when x is equal to 3, simply put x is equal to 3. 2 into 3, it gives you 6. Okay, similarly, if you want to know the corresponding y coordinate when x is equal to 2, put x as 2 here. Okay? Okay, this is going to be 4. So I have one question. For every 1 unit of run in x-axis, okay, when we move along x-axis, it's called a run.
Yeah, and
When we move along a y-axis, it's called a rise. Okay, because looking at it, it's an horizontally, x-axis is horizontally there and the y-axis is vertically there. Alright, so when I ask you, for every 1 unit run in x-axis, how much it is rising in y-axis? 2, isn't it? 1 unit. Say take here, 1 to 2. This is 1 unit. How much it is increased from 2 to 4? 2. Similarly, 2 to 3. 1 unit run in x-axis. How much it is increased from 4 to 6? 2. Okay. So for every 1 unit of run, it is rising in y-axis by 2 units. That is why the slope is 2. Okay. The slope is also defined. The definition of slope is rise by run. Rise by run. Okay. Or y2 minus y or y2 minus y1 by x2 minus x1. Okay. Okay. You pick any 2 points and then substitute these. Okay. So y2 and x2 is 1 point. x1 and y1 is x1 and y1 is 1 point and x2 and y2 is another point. Okay. Okay. Right. This is how you have to do it. For example, if I take a slope, what is the point here? 2, 4. What is the point here? What is this point?
4 and 6.
No.
No, 3 and 6.
3 and speak out.
Yeah.
3 and 6. Okay. So if I take this as the first point and this is the second point, what is the slope? 2. If I take this as the first point and this as the second point, what will be the slope?
2.
2. You will get the 2. Okay, it does not matter whether you take this as the first point or that as the first point. Okay, if you take this as the first point, okay, you will get both negative. Numerator. Okay. Okay, fine. Rise by run, right? So 4 minus 6 by 2 minus 3. This is one way of doing it, and the other way of doing it is 6 minus 4
No,
by
no, no. It should be
3
3
minus
by
2.
2.
Hmm?
3 minus 2.
No,
There.
this is correct only. So what is this? 4 minus 2 is what? Minus 2 by minus 1, which is 2. And here it is 2 by 1, which is 2. Both ways it is, you got the slope as 2. Okay? Okay. Yeah, is it recording?
Yeah.
Okay, alright, yeah. Alright, so this is how the slope is, how the slope, the concept of slope is arrived. Okay, the slope is very important concept to study any system characteristics. You need to understand the slope. Okay, every system, now every system, you take any system, for example, the distance, velocity, the velocity, acceleration, time and distance, time and speed, and not only that, but the human body, like for every chemical reaction. Okay, these graphs are important, and understanding these graphs and the slope, understanding the concept of slope is also important. Okay, so the same thing. Okay, so if it is a straight line, it's easy to figure it out the slope, because when you put a straight line in y is equal to mx plus c format, m obviously represents the slope. Okay, so when you compare this equation with this equation, then what is m here?
2.
2. What is c here for this equation?
0.
0. Okay, okay, this is a straight line equation. Okay, so I'm going to give you another straight line on the same coordinated plane, this one. So what is the line equation roughly? For example, it is cut y-axis at minus 3. So what will be the slope of, what is the line equation for this one?
0.
No. When I say equation, it is not a 0. Yeah.
No
Y
slope.
equals
Y equal to?
minus 3.
Exactly. Yeah, y is equal to minus 3. The line equation for this one is y is equal to minus 3.
The slope is a z.
Correct.
So 0x plus 1.
So 0x plus 0x minus 3.
Yeah.
This is the line equation. Alternatively, you can also write the same for the same thing. You can also write y is equal to the same line equation, 0x minus 3. Isn't it? What is the slope of this one? 0. Because what is m here? 0. Okay. This is straight line equation. That's what the concept of slope. For example, so with a differentiation, for any given equation, you can find the slope. You can find the slope. So the formula for a differentiation is, for example, y is equal to x to the power of n. Okay, when you differentiate it with respect to x, dy, look at it, this is the equation, y is equal to x to the power of n. What is the equation here for this line? X is equal to 2 to the power of x. Assume n is some constant. It can be 1, it can be 2, it can be 0, it can be 5, it can be minus 2, it can be 6, anything. Okay, so when equation is in this format, the differentiation of y with respect to x, this is how you have to write it. Put d by dx on both sides. I put d by dx, y as it is, d by dx is equal to differentiation of, I'm keeping the same thing, x to the power of n. Okay, d by dx on both sides, d by dx I put here, d by dx I put here, x to the power of n. So the formula for x to the power of n, differentiation for x to the power of n is n into x to the power of n minus 1. Okay, the other way is, the power comes as a multiplier here, power comes as a coefficient here, and the power will be reduced by 1. If it is power 3, what will be the power here after differentiation? 2. If a power is 0, what will be the difference? Minus 1. If a power is minus 3?
Minus 4.
Minus 4. Okay, yeah, that's important. Okay, remember one thing. Here it should be constant, and this variable with what you are differentiating should be
At the bottom.
As a base. Okay, it should not be in this format. Okay, there is a lot of difference. The variable is at the power, the constant is at the base. There is a lot of differentiation. Okay, one thing you have to distinguish is that where is x? Where is the location of x? Is it a base or is it a power? Okay, it's easy to get confused. Okay, so I'm going to give you, this is the formula, the main formula. You need to apply this one for any given
No.
equation. Equation is something that should be is equal to, and the y is equal to,
X.
y is a function of x. That is why we have x here. So I'm going to give you y is equal to x to the power of minus 5. What is dy by dx?
Minus I x
Minus
and
5.
then minus
The power comes as a
6.
quotient. X to the power of the power is reduced by 1.
Minus 6.
Minus 6. Okay? As simple as that. Okay. So y is equal to 3. Y is equal to minus 3. I'm taking this equation. Y is equal to minus 3. Can we say this as a? Can we rewrite this one as y is equal to minus 3x to the power of 0? Can we write it this way? There is no x here. But if you want to put x here, you can put x to the power of 0. There is no change between this one and this one. Do you agree? What is x to the power of 0?
0.
1.
Yeah, but the whole thing is 0.
Whole thing is 0, yeah. X to the power of 0 is 1. So you are multiplying minus 3 with 1, which you'll get minus 3 only. Alright?
Yeah.
Yeah, so let's differentiate it here. dy by dx. Whenever there is any quotient like this, any fixed quotient, constant quotient, you can keep it aside. Aside, multiply it, and take the differentiation of this one. What is the differentiation of x to the power of 0?
0.
0.
1.
Okay, the power comes here. No, 0. The power comes as a
0.
quotient into x. Power is reduced by minus 1. Which is 0 minus 1, which is minus 1. Because we have 0 here,
Whole thing is 0.
everything is 0. Okay. So, did it prove that this equation is having a slope of 0?
Yeah.
Okay. Differentiation of any equation gives its slope. Gives its slope. If you want, you can do this differentiation of y is equal to 2x. How much you will get in differentiation of 2x?
2.
2. Okay, let me do it. Y is equal to 2x dy by dx. What we should do? There is a fixed quotient. Keep this aside. Aside as in like keep it there and multiply x differentiation. What is x differentiation? What is x power
1.
here?
1.
1. 1 x power reduced by 1. 0. Okay. So what is x to the power of 0?
1.
1. 2 into 1 into 1. 2 multi. 2. Okay. What is the slope of this one? 2. dy by dx will give you the slope. Y represents the original equation, the original line equation, given equation. When you differentiate it, this is not y. This is dy by dx. There is a difference. What is y here? This is y. Y is equal to 2x. What is dy by dx? 2. Okay? dy by dx is 2. Okay? Instead of y, you can also say f of x. You can also represent this. Some people say f of x also. Okay? In this case, you can write f of x. Okay? Differentiation of, instead of y, you can say f of x. Okay? Instead of writing dy by dx, in your textbook, it is written as f dash x, which is a differentiation of y, which is differentiation of f of x. Differentiation of f of x. Okay? F dash x. Okay? That's the concept of it. So if it is a straight line, you got either 0, either a constant. But there are also some complex
Slopes.
lines, complex shapes. Let's take a shape. Okay, what is the differentiation of x to the power of n? What is the formula?
Times x to the power of n minus 1.
N into
N times x to the power of n minus
n times x to the power of n minus 1. Very good. Very good. Okay, let's erase this one. Okay, so I have an equation like this, which is a parabola. Okay, so what would be the equation for this? It is passing through.
Wow, I
Is that
equal
not a
to x
hyperbola?
square.
Is that not a
Yeah, hyperbola. Yeah.
I equal to x square.
Y is equal to x square. Okay, because it is passing through 0. It is passing through 0. So y is equal to x square. Okay. So what are the roots of that equation?
0.
0.
And
0.
zero.
Is the root. 0, 0 and 0. It has two
0,
roots, but 0 and 0. So that is why it cut here. It cut here. Okay, because both are positive, both are same. So you just touched and gone again. Okay. Okay. Say for example, if there are two roots, so something like y is equal to x minus 3, x minus 2. How can you draw a rough sketch for this equation? The roots are 3 and 2. Where is 3? Somewhere here. Where is 2? Somewhere here.
Yeah.
So, is it facing upward or downward?
Upward.
Upward. Why? Because x square
it is
quotient is
plus.
positive number.
Plus.
X square quotient is positive number. So, that's how you can draw a rough sketch here. Okay, so these are the roots. In this case, the roots are 0. So, that is why both roots are 0. So, that is why it cut here only. Nowhere else. Okay, this is how you can draw a rough sketch for any given quadratic equation. So looking at this one, this is again, what axis is this? X axis. What axis is this? Y axis. So where do you think the slope is 0? At what point the slope is 0?
When it is going down.
Which point? Look at it.
And is the small, like the
Center point.
Center point. Where is center point?
there.
This one?
Yeah.
Yeah, because wherever
It
the line
goes-
is changing its direction, that is the place.
Yeah, but what if it is like so smooth? It went up.
So
like-
smooth, but even then there is a tip. Even then there is a tip. That's what is the concept of tangent. Say for example, this is a circle. How do you define a tangent? A tangent is a line that touches the circle only at one point on the circumference. Okay. Practically, it is difficult to draw, but mathematically, that is what it is defined. Okay, that is how it is defined. Okay. So even however smooth it is, there will be one tip. There will only be one tip. That is the place where it is changing its direction. So there the slope is 0. Okay. Alright. So this is the place where we have a 0 slope. Where do you think the slope is higher?
There. Like
Deshni,
coming-
speak out.
it
Where do you think
going
the slope is
upright.
higher?
So like
The,
up 2 points.
Where the last 2 points.
This point, the slope is higher.
Yeah.
Okay?
Yeah.
Maybe at an infinite point, the slope is higher. How about this point? Is the slope same here and
Same.
here?
Yeah. Yeah.
No, there is a difference.
Yes.
See here, when you're moving an
No,
x-axis, it is falling.
It is
That means it is having a negative slope.
Negative
I-
slope.
Minus infinite.
But it's the same. Like
Yeah, this the value wise it is same. Absolute value wise it is same. But it is having a negative slope.
Negative and then
There it is a positive.
positive.
Okay. Okay, here we are having a 0 slope. Here we are having a increased slope. Like if you go to the end, it is going to obviously having an infinite slope because every point you move, every unit, it is rising sharply. See here, this is 1 point and this is 1 point. See how much it is increased. Here it is increased only this much. For next 1 point, for next another unit in x-axis, see how much it is increased. More it is increased, right? So like this, it is keep on increasing. The slope is keep on increasing as you move to the right. Okay. So looking at the shape, we understand this is where we have a slope is 0. This is where we have infinite slope. This is where we have a minus infinite slope. Not this precisely, but somewhere at the
infinite.
left corner. Okay. Okay. So what is y? Is equal to x square. Okay. This equation represents this hyperbola. Y is equal to x square. We can also write it as f of x is equal to x square. F of x is equal to x square. So let's differentiate it. Differentiation with respect to what? With respect to x only.
f of x
No,
by here.
with respect to
dx.
what means whatever you are putting here down, that is with respect to x.
dx
Yeah,
by
like
dy.
f of x. F of x. It
dx
can be
by
f
dy.
of x.
d f of x
Yeah.
is equal to
dx by dy.
no
dy by dx.
dy by dx or d f of x by dx with respect to x. That is why we put a dx
dy by
down.
dx. dy by dx.
dy by dx. If it is y, then we can say it is dy by dx because it is f of x d f of x by dx. Okay, now what is the differentiation of x square?
2.
Hmm? No.
2x.
2x. Okay, so previously you got a fixed slope. Now here you got a
And x because it changes.
because the slope is changing. It's not a fixed. Here you got you said 0. Here you said plus infinite, and here it is difficult to find with a single
It
point. It
doesn't
is
stay
difficult
the
to
same.
find. But if you imagine you bring that points too close around that point, infinitesimally small. That's called infinitesimally small. Say that again with me. Infinitesimally small.
Infinitesimally
Small. Yeah. Bring down closest like so. This slice it so small. Slice it so small, and then find out the slope. It is possible, right? When I say slope at this point, it's with one point it is not possible, but keep that slicing so small around that point. Okay, just a small bit after that, small bit after before that. Okay, so now 2x. This is y is equal to x square or f of x is equal to x square, whichever is convenient. F of x is equal to x square. So let's plot this one. What is this equation? F dash x. Isn't it? D f of x by dx is also equal to f dash x. What is this one? F dash x is equal to 2x. Let's plot this also. What is this equation? F of x. So 2x. What is the slope of this one? Let's cut it. Okay. Let's cut this one. This is a separate graph. What graph? F dash x. So 2x. So how is it going?
It's slanted.
It is going like this. So what is this line?
I equal to 2x.
Y is equal to 2x. No, f dash x is equal to 2x.
Yeah, or y.
Y is equal to 2x, but in this context it is f dash x. Okay? F dash x is equal to 2x.
No, it's a slope, it isn't an equation.
It is not an equation. It is the equation for the slope. Okay. You found the slope, and the slope is 2x. When you plot that slope in a coordinated plane, you got this shape. So this shape tells, is this a line by itself? No, this is the slope for this line, for this hyperbola. Okay, so what is f dash x here?
It's
0. What is f dash x at the top, at the
Infinite.
right top?
Infinite.
Put x as infinite. That means you are going. That is infinite. What is f dash x here on the left bottom? Minus infinite. Okay, that gives the slope
No,
here.
but it can.
Say for example, if you
be
have to.
infinite. But because it is going up, so it can be infinite.
Minus infinite na? On the y-axis,
Yeah,
what will be?
but if it isn't, no, but it is going up, right? So
Up.
it should
That means it is
be
going infinite.
Yeah.
Okay.
Yeah.
When x is infinite, y is also infinite. Yeah. So for example, if you have to find the slope here at this particular point, for example, x 3, and x is 3. And what will be the y here? 3 square, which is 9.
Fine. No, it should be bit.
Bit, yeah, I agree. Yeah, it should be narrower. I agree. Okay. X square is 9. So at this point, what is the slope when x is equal to 3?
2x.
When x is equal to 3?
No. If we have 2, and it is easier to swim.
Then it is easier. But that is what I said. 2 points are needed. But assuming 3 is the point and you take some small slice around 3.
Yeah,
Okay, so what will be the slope at this point? This is the slope equation.
Yeah.
Tell me.
So 2 times 3.
Exactly. 6 is the slope. At this point, 6 is the slope.
But it's not the same throughout the actual.
Exactly. Yeah, it's not the same
Changes all
throughout.
the time.
Yeah. So when it is 4, the slope will be,
8.
this is the slope equation, 8. When it is 5, the slope is 10. When it is 10, the slope is 20. The slope is varying. Okay, the slope also has a variable in it. The slope also has a variable in it. Okay, that's the conceptually how you should understand the differentiation. Once you understand it, it's damn easy. Okay, you can crack any sum. Just visually you can crack it. Mathematically you can crack it. By with formula you can crack it. Okay, the number of ways you can crack it. Okay, that's what the meaning of a differentiation. Let's quickly take some equations. Y is equal to x cube to x cube. What is the differentiation of it? So I like to write this way.
6x square.
6x square. Okay, 2, keep it as it is. Okay, bring the power as a quotient. I brought the power as a quotient and reduce the power by 1, which is 2. 6x square. Okay, now y is equal to minus x to the power of minus 5. Say I'll also put some quotient here. Let's do it together. Yeah, dy by dx.
15x to the power
Okay, 15 minus 3 and the power comes here. Isn't it, Dashni? Yeah, 15 x to the power of
Minus
6.
minus 6. Okay, like that. So y is equal to x cube plus 2x square. Let's do this differentiation. I'm going to erase this one. Hope you understand the theory behind this differentiation.
3x squared plus 2 times.
dy by dx or y, yeah, dy by dx. I
3x
prefer
squared.
writing it. Some otherwise in examinations you may get a f of x. Find the f dash x. That means it is a differentiation of f of x with respect to x. Okay, so you
Is
have
it
to
7x
read it out.
squared?
It's a differentiation
Is
of
it 7x squared?
no 3
3x squared.
3x square plus
2 times 2 times
4.
6.
Power is reduced by 1 x.
X.
Yeah, this is what the differentiation is. When you plot it, when you plot this equation, and at any point if you want to find the slope, you have to substitute that point here in this equation to find the slope. Okay, not this point. This point gives the original original curve
Curve equation.
equation. This is the slope equation
At that particular point.
at that particular point. Any point if you want to find. I think you got it very nicely. It deep into your mind. Yeah. Okay, so let's do it. F of x is equal to minus 2x square plus 3x. Let's find f dash x. What is f dash x? It's a differentiation of f of x with respect to x. What is f dash x here?
Minus 4x.
Minus 4x. Super. Yeah. Plus
Plus
3.
3.
3.
Okay. Alright. So one more. F of x is equal to 2x to the power of minus 3 plus 5. Let's do the f dash x. What is it?
Minus 6x to the power of
Square.
minus 4
Minus 4.
plus 0.
0. Exactly. Yeah. So you can remove that 0.
Maybe and we simplify it again.
This one?
No, that answer.
No, you cannot simplify it. How
No,
can you-
but
This
yeah,
is
we can like I can in the slope of the thing.
this one, huh?
Yeah.
How can you
slope.
find? This is the slope equation.
Yeah, but for the art and we do like
Another slope, huh?
another slope.
Yeah, then it is a f double dash x. Yeah, you can find the slope.
Uh-huh.
Distance, time. If you find the differentiation, you'll get a speed, velocity.
Mhm.
Okay. Displacement, time. If you do a differentiation, on y-axis it is displacement, on x-axis it is time. If you do a differentiation one time, you'll get a
One
Velocity.
slope.
you'll get velocity. If you differentiate it one more time,
Acceleration.
you'll get acceleration. Okay. Differentiation of velocity with respect to
As
differentiation of displacement.
acceleration, what does it mean?
Change in the speed. What is the speed? What is the velocity? Change in the displacement.
Slope.
Change in the displacement. Displacement is like a distance. Change in the displacement is a velocity. Change in the velocity is a
Acceleration.
acceleration. Okay, that's what the double differentiation. If you want to double differentiation, you can do it. You can do it any number of times. There is no problem.
Or maybe 3 times.
3 times also you can do it. Okay. All right. Simple, isn't it? Okay. So I'll say f of x is equal to minus 7. What is the f dash x?
Zero.
Rashmi, what is f dash x?
Zero.
It is 0 because it is constant. Okay. F of x is equal to pi. What is f dash x?
Zero.
0. Okay. F of x is equal to e. What is f dash x?
Zero.
0. Okay. Okay. What do we have? What do we have
To
here?
the power of x.
Okay. So,
F of x equals
so far we have seen the equations where x is at the base. For example, f of x is equal to 2x to the power of minus 3 plus 6x. So here also the x is at the base, and here also x is at the base. Let's quickly do f dash x here. What is f dash x?
minus 6x to the power of minus 4.
Minus 6x to the power of minus 4 plus
6.
6. Okay? Okay. So there is also certain scenarios where x is at the power. Say for example, f of x is equal to
E to the power of x.
3 to the power of x. In such case, the f dash x, the formula for f dash x is
3 to the power of x
3
times
to the power of
log,
x times log times
log
3.
x base 3.
log
E base 3.
log 3 base e.
Oh, log 3 base e.
Log 3 base e. Okay? Log 3 base e. Or you can also say ln 3. ln means base e only, natural logarithm. Okay? ln 3. That is also fine. Or log, if you want to put a log, put a log. Yeah. So f dash x is equal to e to the power of x.
So on your plot on a graph.
3 to the power of x. Huh?
Yeah.
If we can do it, yeah. Put x as 1, put x as 0, x as 3. So 3 to the power of x. So it's kind of rising exponentially. Something like this. So this one also you can
then
do it.
another
Where,
another
yeah, 3 to the power of x. Here also, the slope is increasing.
no
Exponentially.
but it should be the full thing. It's only half.
Which one?
No, the plotting.
Mm.
It's only half up.
It will be full, yeah. You can put x as 0. How much you will get? 1. It is going to touch at 1. Okay, so ideally it is going to be like this. When you put x as 0, it will be 1. When you put x as infinite, it will touch 0. It will come closer to 0. It will never touch 0, but it will come closer to
that
0.
one, yeah, I know that.
That is the
yeah, I
one.
know.
So, okay. So if you draw it, where do you see the slope highest? P.
The infinite.
Where do you see the slope lowest as you come closer to minus infinite? X is minus infinite.
No.
0. No. When you go x as minus infinite, the slope is coming to 0. It almost touches x-axis. It almost becomes a flat. Yeah. If you want to draw, you can draw it like take this, plot it here, and you plot it here, and observe the behavior. Plot this also. Okay. So if you want to find ln 3, what is ln 3? Keep it in calculator. It is almost the same, but it is the same, but it is multiplied by some factor, some constant. This is ln 3 is some constant, isn't it? Do you agree?
Yeah.
ln 3. How do you find ln 3?
Through
Calculator, yeah. So let's do Teshni. 5 more minutes. We're going to finish it up, wrap it up, yeah. E to the power of x. What is f dash x?
E
E to the power of x
times
log
log e base e.
log e base e. What is log e base
equal
e?
to 1.
Is 1. So e to the power of x. So this is a special function, e to the power of x. The slope equation of e to the power of x is itself.
Well, on plot
Same way. Instead of 3, it is e to the power of x. What is e? 2.7 something like that. So here also it is the same. more or less the same, but it may be shifted upward or downward. The shape wise it is the same only. Shape wise it is the same only. All right. Let's pick one question from the textbook. See what kind of questions they're asking. Okay, there is a function f of x is equal to. Five plus 2x minus 2x square. Okay. The function is shown together with the tangent y is equal to f of x at point. Okay, this function is something like that. Is it upward or downward? This function, this hyperbola, is it upward or downward? This equation, when you plot it in a coordinate plane, is it going to face upward or downward? Downward, because we have a negative power. Okay, the graph is also given, and the graph is
negative quotient.
because x square is having a negative quotient. What is that quotient? -2. Okay, so that's a curve. Okay, this is f of x. Okay, f of x, this is curve, and there is a tangent, and the tangent is cutting this one, this hyperbola at a point, and that point is 2, 1. Okay, there's a point, there is a tangent which is cutting that hyperbola at 2, 1. Okay. Okay, the first question, write down f dash x, the derivative of f of x, differentiation of f of x. Write down f dash x. That is the first question. Let's do it. What is the differentiation of? Let's do it quickly. What is differentiation of 5? Huh? 0. 0. What is the differentiation of 2x? 2. What is the differentiation of minus 2x square?
Minus 4x.
Minus 4x. Okay. That is the differentiation. Okay. If you further simplify it, it's going to be 2 minus 4x. But if you want to write it properly, it's going to be minus 4x plus 2. Okay. Usually higher power should be at the beginning. Okay. What is the power of this one? 2?
0.
0.
No, x power.
X power 0. Yeah. Okay. Okay, that is the first question. Hence, find the slope of the tangent y is equal to f of x at 2, 1. Hence, this point, we need to find the slope. Slope of this tangent at 2, 1. Okay. So, if you want to find the slope,
Keep 2 in place of x.
2, yeah, exactly. Yeah. Keep 2 in place of x. You understand? Find the slope of this tangent. This tangent equation is not given. He only said that it is touched one point.
And they also didn't give any other point on the tangent.
Any other point, okay? To find this line equation, you need at least 2 points or 1 point, 1 slope. Okay? If those 2 things are given, you can find the slope. But in this case, only 1 point is given.
Put 2, 1 in
2, 1. So find the slope of this line at 2, 1. Okay. So this is the slope equation. The slope of this line. Okay. It is cutting this one. So to find the slope, of this line at 2, 1, we need to put
X as 2.
x as 2.
2 or 1.
No.
Yeah, so what about the 1? 1? No, like, so what is the use of 1?
This is a point. Every point will have x coordinate and y coordinate. X is 2 and y is 1. Okay, so what is the use means? It's a point. Every point will have a 2.
So then substitute 2.
Yeah, we need to substitute 2. But where, which equation we need to substitute? Find the slope of the tangent.
Wait, actually. Is it in the actual one or is it in the slope?
In the slope, what we need to put it.
Yeah.
Okay?
Yeah.
So when x is 2, we keep minus 2. 4 into 2 plus 2, which is minus 8 plus 2, which is minus 6.
Mm-hmm.
Okay?
Minus
This-
6 is the slope of that line.
Minus 6 is the slope of this line. What is the slope of this one? Minus 6. Isn't it? It's falling downwards. That means it is having the slope as minus 6.
Mm-hmm.
And obviously, find the equation of the tangent to the curve. Find the equation of the tangent. So you know the slope. You know 1 point. How do you find out the equation?
Easy. Minus 6 equals y2 minus y1 by x2 minus x1.
No, the slope is already given.
Yeah.
There is no other point is given. One slope is given.
Oh, okay.
Y is equal to
Mx plus c.
mx plus c. What is m? Minus 6. You keep this point here.
2.
2
Find
plus c. Y is equal to how much? 1. Find c. Minus 12 plus c is equal to 1. So c is, if it goes the other side, it is going to be 13. Okay? Now you have a slope.
Minus 6x plus 13.
You have a c. So y is equal to minus 6x plus 13. This is the slope. Okay? Yeah. At what point this is going to cut the y-axis?
13.
13. What is this point? It is
Was
0, comma 13.
0, comma 13.
0, comma 13. Very good. That's the third question. Find the coordinate of the point where the tangent intersects the y-axis. Exactly. It's already, we already discovered it.
Mm-hmm.
Find the coordinate of the tangent which intersects the y-axis. 0, comma 13.
Mm-hmm.
We already did. Okay. That's how the typical questions are.
Mm-hmm.
Okay. Okay, we'll end for now and we take on some other session. Thank you for watching.